You are on the ground tonight, not in a tent. No walls, no door, no lock. Just open ground, a dying fire, and a body that has completely surrendered to unconsciousness for the next 8 hours. You cannot run. You cannot fight. You cannot even scream without a few seconds of helpless confusion first. From a purely mechanical standpoint, you are the easiest meal in the forest, and almost nothing eats you. That is the question. Not the obvious one about whether predators are dangerous. They are, and they can be. And occasionally they are. But the real question is why, across 100,000 years of sleeping humans on open ground in landscapes filled with lions and leopards and hyenas and wolves, something in the predator's calculation almost always lands on no. Not tonight. Not that one. Because it does. And the reason it does is almost nothing like what you have been told. The common version goes something like this. Predators avoid humans because we have weapons. We learn to use fire. We hunt in coordinated groups and we punish anything that threatens us. That is the story. Spears, fire, the smart ape at the top of the food chain. That version is incomplete. Not wrong about the weapons, not wrong about the fire, but missing roughly 2 million years of context about what was actually happening in the bodies and behaviors of animals sharing landscapes with early humans, and why those animals developed what researchers now recognize as a deeply embedded, cross-species, cognitively complex response to the specific threat signature that humans broadcast even while asleep. Let us start with the landscape. For most of human prehistory, you were not the apex predator. That is a recent development and a somewhat flattering one. For the vast majority of human evolutionary history, the genus Homo was medium-sized, relatively slow, not particularly well-armored, and living in environments occupied by ambush predators that had been refining their technique for millions of years longer. Saber-toothed cats, cave lions, spotted hyenas in clans of 80. These were not animals that made mistakes. And yet, the fossil record of human-predator interaction, analyzed in detail by Robert Berger and his colleagues at the University of the Witwatersrand in the 1990s, and revisited in later studies on predation marks on hominin bones, tells a mixed and specific story. Yes, early humans were sometimes eaten. The evidence is unambiguous, but the pattern of which individuals were taken, and when and how, is not random. It clusters around specific conditions. It is not the sleeping person beside the fire who shows up most consistently in the archaeological record of predation. It is the isolated individual, the peripheral one, the one separated from the group in conditions that disrupted the normal signals, which suggests that the sleeping person beside the fire was not, as a rule, being taken. Something was protecting them, and it was not just the fire. Here is what was protecting them. Smell. Your body at rest is not silent. It is broadcasting a continuous chemical signal, and that signal contains information that any predator in your vicinity has been reading for its entire life. The specific cocktail of human scent, which includes compounds produced by skin microbiome, sweat gland activity, and metabolic processes that are measurably distinct from every other large mammal in the same ecosystem, is something predators encode early and encode deeply, not as a deterrent, necessarily, but as a category, a thing that has specific behavioral history attached to it, and the behavioral history attached to humans is not peaceful. Let me throw something at you. Researchers studying predator-prey cognition, including work by Liana Zanet at Western University, and her collaborators have found that the fear of large predators in prey animals is well understood. But less studied and more surprising is what Zanet's team documented in the reverse direction, that many large predators show measurable behavioral suppression. Reduced foraging activity, increased vigilance, changed movement patterns, specifically in response to recorded human vocalizations, even when no other threat is present, and even in populations with no direct negative experience of humans. The paper, published in Current Biology in 2019, found that mountain lions, leopards, and other apex predators treated the sound of a talking human as a threat signal more reliably than the sound of large dogs, gunfire, or other predators. In some cases, the response was more intense than the response to direct competitor species. Think about that. A mountain lion in a landscape it has occupied for generations hears a human voice from a speaker hidden in a bush, and its stress response and movement suppression are comparable to or greater than its response to being stalked by a rival predator. That is not a learned behavior from a few bad encounters. That is something deeper. That is what a species looks like when it has been encoding a particular threat across enough generations that the encoding begins to resemble instinct. And humans have been broadcasting that threat signal for a very long time. Long enough that, as anthropologist Mark Gurven at the University of California, Santa Barbara has noted in his work on contemporary forager populations, the Tsimane of Bolivia still sleep largely in open air or semi-open conditions in a landscape with large predators. And predation rates remain low in ways that cannot be fully explained by active deterrence alone. Something in the ambient human presence itself acts as a suppressor. Your sleeping body is doing something. Even without fire, even without weapons raised, just the smell and the sound of you breathing, at scale, distributed across a group, sends a signal into the dark that most predators have learned across evolutionary time to treat with considerable caution. Now here is the turn that the story almost never takes, because this picture of a remarkably effective passive deterrence works best when you understand what humans actually did to earn that reputation. It was not gentle. For the hundreds of thousands of years that predators were encoding the human threat signal, humans were doing something quite specific in return. They were not simply defending themselves, they were hunting, actively, systematically, and at scales that no other terrestrial mammal approaches. The evidence for coordinated human hunting pressure on large carnivores is sparse, but real. Studies on cave lion and spotted hyena population declines in Europe, analyzed by researchers including Kajus Diedrich, suggest that human hunting pressure was a contributing factor in the megafauna extinctions of the late Pleistocene. Not alone, not entirely, but in the picture. The predators that survived into the current era were, broadly, the ones that developed sufficient caution around humans. The ones that did not were gone. Natural selection is not subtle. What you are left with in every landscape that humans occupied for long periods are the descendants of the most human-cautious individuals, the ones who learned fastest, the ones whose instinct to suppress activity around human signals was strong enough to pass on. The sleeping human in the forest was not being protected by courage or by weaponry alone. The sleeping human was surrounded by the evolutionary memory of every animal that ever failed to treat humans with sufficient caution. That is an uncomfortable thing to sit with, because it means the relative safety of sleeping on the ground in a predator-rich environment was purchased across deep time by something that looks, from the other side, like a kind of terror. Not just humans being afraid of the dark, though that was real and earned, but the dark being afraid of us, systematically, heritably, across millions of individual lifetimes in which the wrong read of that signal meant death. We built the quiet around our sleeping selves, one dead predator at a time. And that quiet persists, in ways you can still feel if you know how to listen. There is a documented phenomenon in contemporary wildlife research called landscape of fear, formalized by Joel Brown and colleagues at the University of Illinois, which describes the way prey animals modify their behavior across an entire landscape in response to the perceived presence of predators. Not the actual presence, just the perceived possibility. The browsing patterns change. The water access times change. The movement corridors shift. The whole ecosystem reshapes itself around a threat signal that may be invisible. Humans are in that picture too, not as prey, as the signal. In every landscape where humans sleep regularly, the nighttime ecology reorganizes itself slightly. Not completely, not perfectly, not without exceptions and tragedies. But the orientation is consistent. The larger predators move when the human presence signals itself strongly. The mid-level predators calibrate their risk accordingly. The whole nocturnal system adjusts, in small and large ways, around the chemical and acoustic signature of a species that earned its reputation the hard way. Tonight, if you sleep outside, something in the dark will smell you before you know it is there. It will pause. It will run a calculation that is older than language, older than your species' current form, older than the fire beside which your ancestors slept and did not get eaten. That calculation will weigh your signal against a threat history encoded so deeply it functions like knowledge. In almost every case, it will move on. Not because you are harmless, because it knows better. The forest remembers.